Okay, in this video, I want to explain about my research about performance analysis of BFS and DFS algorithm in graph exploration. Before I will explain, I want to introduce myself. My name is Putu Teoriana. With my last three digit of my student ID is 029 and I'm from EE class. Graph exploration is a crucial topic in computer science, especially in navigation system, artificial intelligence, and network routing. Two of the most fundamental algorithms used for this purpose are BFS and DFS. While both are classic traversal method, their behavior and efficiency can differ significantly. Therefore, selecting the right algorithm is critical depending on the graph structure and application goals. So this research will answer this following question. So the first one is how do BFS and DFS perform in graph exploration, and in what scenarios is BFS better than DFS and vice versa. And then the last question is how does graph size affect the efficiency of both algorithm. So for the objective, we will evaluate and compare BFS and DFS on two types of graph. First one is unweighted graph. So unweighted graph is the all edge have the same weight or no weight, such as maze, and then weighted graphs. For the each edge has a certain weight, like geographical map. And then for the comparison matrix, I will use execution time, memory usage, and path efficiency. Let's review both algorithm. So BFS will explore the graph level by level using a queue. It is ideal for finding the shortest path but consumes more memory. And then DFS is goes as deep as possible along each branch before backtrack, typically using a stack or recursion. And it's faster and use less memory, but it may not find the shortest path. So this research is using a quantitative experimental method. So for the first data set, using a 12 times 12 maze with three variation of maze, like normal, with trap, and with dead ends. And for the second data set is a real world geographical map with 8 point and weight edge representing distance and travel time. And there is a table for detail of distance between nodes with a travel time of each edge. After doing the experiment, we got the result for the first graph, which is the maze. So there we can see for the maze one, there's a BFS taken less path than the DFS. And then for the time execution, it seems like DFS is much faster than BFS, and also DFS also have less memory consumption than BFS. For the second maze, we can see slight differences for the path that this algorithm taken, which is BFS. BFS still slower, and for the time exception is there is a slight difference, and for the memory consumption is same, slight different. And then for the third math, and then for the third maze, there is same like maze one. There's bigger differences between this algorithm. Like BFS still have lower path taken than the DFS, and for the time execution, DFS is much faster, and for the memory consumption is slightly different between these two algorithms. And this is the base visualization. Now I will explain about the geographical map result. So we can see the table here. Uh, BFS again, the BFS get the shortest path from node A, C, H, and G, where the total distance is 4,600 meter and 12 minutes of travel time. Meanwhile, the DFS taking the almost twice, yeah, almost twice path than the BFS from A, B, C, D, E, F, G, with twice total distance and also twice travel time. But the DFS have faster time execution, and also two times smaller memory consumption. There, as you can see, the visualization, and then we can go to conclusion. So the performance comparison of BFS and DFS algorithm in graph traversal show that each has its own advantage and disadvantage, depending on the context and search objective. BFS excel at finding the shortcut path, as we know before. BFS is much better searching the shortest path than DFS in both unweighted graph like maze and weight graph like on geographic maps, but it requires more memory due to its use of a queue. Conversely, DFS is more memory efficient, and DFS can explore path more quickly in some cases, but it often results in inefficient path. In small to medium scale graph, the performance difference is not significant. However, in large and highly branched graph, BFS experience increased memory load, while DFS is more prone to finding suboptimal path. Therefore, BFS is more suitable for optimal path finding, while DFS is better suited for quick exploration or system with limited memory. And thank you for watching. I hope you understand about this research